In this lesson, I want to give you the architecture level understanding. I'm going to give you 10 AI systems. We're going to go across 4 domains, 4 pillars: perceive, reason, act, observe. All right, welcome into lesson 1. This is the spectrum from static AI to full autonomy. So here's the problem. Most people use the word AI to describe everything, from a spell checker to a system that can autonomously research, plan, and execute a multi-step task with no human touching it. It's the same word, but they're wildly different things. And it's not just sloppy language. This creates false expectations, it leads to bad architecture decisions, and it burns a stupid amount of engineering effort building the wrong thing. So in this lesson, I'm going to draw out the lines clearly. By the end, you'll be able to look at any AI system and know exactly where it sits. And for once, someone can say AI agent and you actually know what it means. The first mental shift I want you to make is this. Autonomy is not a switch. It's not on-off, agent or not agent. It is a spectrum, a continuum that runs from systems that do exactly one thing when you tell them, all the way up to systems that pursue a goal across time with barely any human direction. And here's why the spectrum matters. At each level, the system gains something genuinely new. And that new thing tells you 2 things at once: how much power you're getting and how much risk you're taking on. Those always come together. More autonomy and more capability, more risk, always. So let me walk you up the ladder. We have 5 levels. Level 1, the LLM API call. Single prompt in, single completion out. That's it. No memory, no state, no action. You send text, you get text back. It's a stateless text transformation. It's very powerful, but it doesn't remember anything you said, and it can't do anything. Level 2, the chatbot. Now we add multi-turn conversations. It maintains context across turns. It could refer back to what you said 3 messages ago. But notice, it still only produces text. It could talk about doing something, but it can't actually do anything. Level 3, here's my favorite, automation. Here, AI gets embedded in a workflow, and now the system can trigger real actions. And this is the part that most people miss. It's following a predetermined script. The branches were written in advance by a human. The AI might pick which branch, but it's choosing from a menu you wrote. Level 4, the agent. This is a big one. Perceive, reason, act, observe in a loop. The system chooses which tools to use. It adapts based on what it sees. It's goal-directed. The path isn't written in advance anymore. And level 5, the agent network. Multiple agents coordinating, specialization, parallelism, delegation. One agent decomposes the task while others execute the pieces. We cover this fully in module 4, so park it for now. Now, I want to walk through the jumps between levels, because the jumps are where the real understanding lives. Level 1 to level 2, that jump is about memory. The chatbot can refer back to what was said before. That's the whole upgrade there. Level 2 to level 3, that jump is about action. The system can now do things, not just say things. But, and I'll keep hammering this, that action is scripted. You, the developer, wrote the branches in advance. And then there's the jump that this entire curriculum is built around. Level 3 to level 4. This is where the system stops following a script and starts making decisions. An agent at level 4 looks at the situation in front of it, reasons about what to do next, executes something, observes the result, and then reasons again. The path is not predetermined. The model chooses it. That right there is what makes something agentic. And here's the catch. It's the exact same property that makes it harder to predict, harder to test, and harder to govern. The thing that gives it power is the thing that makes it risky. You don't get one without the other. So if you remember one thing from this lesson, remember this. The thing that makes something an agent is not that it uses AI. Everything on the spectrum uses AI. Level 1 uses AI. A chatbot uses AI. An automation uses AI. What makes it an agent is that the AI decides what to do based on what it observes, instead of following the path that you pre-specified. The model is the decision maker, not just the executor. Say that back to yourself. The model is the decision maker. That is what an agent is. And that one sentence is the spine of everything we're going to be building. So a quick word on level 5 before we close, because people get intimidated by it. Agent networks sound like a different species. They're not. A network is just agents, each running their own loop that happen to talk to each other. One plans, one researches in parallel, another synthesizes the results. But fundamentally, it's just agents all the way down. The architecture adds coordination. It doesn't add a new type of system. So once you understand level 4, you already understand the building block of level 5. Now, let me save you from the single most common mistake I see teams make. They build a level 3 automation, they pack it with branching logic, dozens of if, then, this, that statements. It looks sophisticated and it feels smart, and then they call it an agent. It isn't. Here's the test. If you wrote all the branches of code, then the AI is not deciding. You are. The AI is just classifying inputs into the buckets you already wrote. That could be a genuinely useful system. In fact, most of the things that I build are level 3 automations for my clients, because level 3 automations can solve real problems, but it's not agentic. And the moment you hit a situation you didn't anticipate, an edge case that doesn't fit any of your pre-written buckets, it breaks because there was never any real decision making in there to begin with. So when someone tells you they built an agent, the only question that matters is, did you write the branches or does the model choose the path? That answer tells you everything. So that's the spectrum. 5 levels and one line that matters more than all the others. The jump from level 3 to level 4, from following a script to making a decision. In the next lesson, we're gonna crack open level 4 and look at what's actually inside an agent. The 4 pillars that every single agent has, no matter how complicated the framework wrapped around it. Once you've got those 4, you'll never be fooled by a fancy looking automation again. All right, real quick before we dive into lesson 2, if you're enjoying the content so far, I run a school community that will go so much more in depth than it does on this video and show you exactly how to build your first AI agent step by step, taught by me. We also have weekly coaching calls, as well as a community of like-minded business owners and AI enthusiasts who are building AI agents right now. If you're interested in joining, I'll leave the link in the description below. Let's move on. In the last lesson, we drew the line. Level 3 is a script, level 4 is an agent. And the difference is that the model decides what to do next instead of following the branches you wrote. But that raises the question, what is actually inside a level 4 agent? What are the parts? Because here's the thing, people wrap agents in these big imitating frameworks, and they start to think that the framework is the agent. It isn't. If you strip any agent down to its essentials, the most complex one you've ever seen, you find the same 4 capabilities every time. And we call them the 4 pillars. And once you can see them, you can never unsee them. Lesson 2, the 4 pillars of agency. All right, 4 pillars. Perceive, reason, act, observe. You remove any one of them, and what you got is no longer an agent. It's something less. Let me take them one at a time. Pillar 1, perceive. The agent can observe its environment. And environment is a broad word here, on purpose. It means something like the user's message, but also the results of previous tool calls, retrieved documents, database records, API responses. Anything that lands in its context window, that's perception. Without it, the agent is blind. It can't respond to the actual situation in front of it because it can't see the situation at all. Pillar 2, reason. The agent can interpret what it perceived and decide what to do about it. It can take a goal and break it into steps. It can weigh options. It can recognize, and this is underrated, it can recognize when it doesn't have enough information yet. The language model does the heavy lifting here. This is the brain. Without it, the agent is reactive instead of deliberate. It can't plan, and it falls apart the moment it hits something new. Pillar 3, act. The agent can do things in the world through tools. Send an email, query a database, run code, call an API, write a file. These actions have real world effects. And this is the exact pillar that separates an agent from a chatbot, because a chatbot can only produce text. Without act, your agent is just a very smart chatbot. It can advise you, but it can't execute. Pillar 4, observe. Or as I like to say it, observe and learn. The agent gets feedback from the action it just took. A return value, an error message, a confirmation, and it uses that feedback to inform its next decision. This is the one that closes the loop. Without observation, there is no loop at all. The agent acts blindly and has no idea whether it worked. Now, watch what happens when you put those 4 in order. Perceive, reason, act, observe, and then back to the top. Perceive, reason, act, observe. That cycle is what we call the agentic loop, and it keeps running until one of 3 things happens. The agent decides that the goal is met, or it hits a stop condition you set, or it gets stuck and escalates to a human. Here's what I need you to really internalize. Every agent you will ever encounter, no matter how fancy the framework wrapped around it is an implementation of this loop. That's it. That's the whole thing. So the key insight for this lesson, the loop is the thing, not the model, not the framework, not the tools, the loop. And here's why that's so practically useful. When you have an agent misbehaving, when it's doing something dumb and you're almost always debugging a broken loop, one of 4 things went wrong. It either perceived something wrong, it reasoned incorrectly, it acted on bad information, or it couldn't see the result of what it did. That's your entire debugging checklist right there. 4 boxes. We come back to this again and again and again. All right, let's go over this quickly because people always ask me this. Why do I say observe and learn? Why 2 words? Because there are actually 2 timescales of learning happening. The first is within a single run. The agent runs a search, gets nothing back. Notices it got nothing and tries a different query. That's the agent learning inside one session. We call that in-context learning, and it's fundamental to what makes agents adaptive in the moment. The second timescale is longer, over many sessions. An agent can be updated based on aggregated outcomes, user feedback, evaluation data. That's a separate engineering problem and we cover it later. But it's the same underlying idea, the system improving based on the gap between what happened and what was supposed to happen. Here's the point for now. An agent that can't learn from its own observations within a single run will repeat the same mistake in that same run. It will run the bad search 5 times. That's a fundamental failure mode, and you design against it from day one. Which brings me to the classic mistake here, giving an agent tools, but no feedback mechanism. Picture this, your agent can call an API. This is pillar 3, act, check. But the result of that API call never makes it back to the context window. So the agent fires the action off into the void, and it never finds out what happened. It has act, but it doesn't have observe. What you get is an agent that confidently does the wrong thing, repeatedly, with zero ability to self-correct. because it literally cannot see that it's failing. If you take one practical warning from this lesson, it's that an action without observation is not agency. It's just noise with a bunch of steps with consequences. So we have 4 pillars: perceive, reason, act, observe, arranged in a loop. That loop is an agent. Now, we've said twice now that the difference between an automation and an agent is that the model chooses the path. In the next lesson, we're gonna put those two things side by side: real code and automation versus an agentic loop. And you'll see exactly where the decision-making moves from your hands into the models. This is the most important distinction in the whole curriculum. So I'll see you there. I'm gonna make a strong claim, and I'm gonna spend this entire lesson backing it up. The distinction between a linear automation and an agentic loop is the single most important line in this entire curriculum. Not one of the most important, the most important. And here are the stakes. If you get this wrong, you will spend months, real months, building sophisticated looking systems that are actually just complicated pipelines. They look like agents, they demo like agents, and then they shatter the instant something happens that you didn't design for. So let's make sure you never make that mistake. This is lesson 3, linear automations versus agentic loops. All right, so let's start with linear automation, because I don't want you to think that this is the villain of the story. It isn't. A linear automation is a fixed sequence of steps. Now, it can branch, and you've seen this. A customer sentiment is negative, route to tier 2 support. Otherwise, send the FAQ. That's a branch. But here's the key. Those branches are predetermined. A human wrote them. The AI might classify the situation. It might decide which branch we're on, but it does not choose what happens next from an open-ended possibility space. It picks from a menu you wrote in advance. And I want to defend automations for a second, because the instinct after a course like this is to think agents are good and automations are primitive. So wrong. Linear automations are excellent for well-defined repetitive processes with predictable variation. In fact, I made an entire short-form series about AI automation for businesses because that's how much I believe that AI automation is actually very good for businesses. They're fast, they're cheap to run, they're easy to test, and they're easy to audit. For a huge number of real business problems, an automation is exactly the right tool, and reaching for an agent would be over-engineering. The mistake isn't using automations. The mistake is using an automation where you actually needed genuine decision-making, and then being shocked when it breaks because in an edge case you never anticipated. Let me show you one in a no-code tool called NAN, a support ticket handler. We classify the sentiment, that's an AI call. Then, if it's urgent, escalate. If it's billing, route to the billing queue. Otherwise, send the standard FAQ template. Look at that structure. The AI classifies, but the human, you decided what every single classification means. You wrote urgent ghost escalation. The model didn't decide that, you did. Now let's just go back and look at the other thing, the agentic loop. An agentic loop does not have predetermined branches. The agent reads the situation, decides what tool to call, if any, calls it, reads the result, and then decides what to do next. And the critical part, the path through the problem is determined at runtime by the model, not at design time by the engineer. That's the whole ballgame, design time versus runtime. In an automation, the path was decided at design time, when you were writing the code or setting up the no-code tool flow. In an agent, the path gets decided at runtime while it's running by the model in response to what it's seeing. Here's that in code. While goal not met, already different. Notice in a loop now, not a straight line. Perceive the context. What do I know right now? Reason about it. What should I do next? And then the model picks. Maybe it's a tool call, so we execute the tool and feed the result back into context. Maybe it's a response, so we answer and break. Maybe it's an escalation, so we hand off to a human and break. The comment at the bottom of that block is the whole lesson. The model chose which branch, not the engineer. In the automation, you wrote the branches. Here the branches are open-ended, and the model navigates them live. And that brings up something you have to design for. The loop continues until a stop condition is met. The goal is achieved, or the agent escalates, or it hits a safety limit. That stop condition is one of the most important things you will ever design, and people skip right past it. Why does it matter so much? Because an agent without a clear stop condition can run forever. It will loop and loop, burning tokens the whole time, and sometimes causing real damage as it goes. We'll come back to a horror story about exactly this in a later lesson. But for now, just memorize this in your brain. Every loop needs a way out. One more piece, and this one's more subtle, but it matters. State management. In a linear automation, state is easy. You pass a data object forward. Each step reads from it and writes to it. Simple shared record. An agentic loop has a harder problem. The agent state is its context window, and the context window is finite. So as the agent takes more steps, it accumulates more observations, more tool results, more reasoning. It eventually has to make decisions about what to keep, what to summarize, and what to throw away. That's called the context engineering problem. And it's one of the primary reasons agents fail in practice. We dig into it properly in Module 3. The takeaway for now, the longer an agentic loop runs, the more it matters how you manage what's in the loop's working memory. A well-designed agent doesn't just act intelligently, it curates its own context intelligently as it works. So here's the insight that ties this lesson together. Goal-directed behavior is the defining characteristic of an agentic loop. The agent is not executing a plan you wrote. It is pursuing a goal you specified and choosing its own path to get there. And that completely changes your job as the engineer. Your job is no longer write all the branches. It can't be. The branches are infinite. Your job becomes three things: specify the goal clearly, give the agent the right tools, and build the right guardrails. That's the shift of all of this, from writing every path to defining the space the agent gets to operate in. So that's the line. Automation, the human pre-specifies every branch. The agentic loop, the model decides it at runtime. Memorize the test from lesson 1. Did you write the branches, or does the model choose the path? In the next lesson, we zoom into the 3 capabilities that actually make this possible: tools, memory, and planning. Because saying give the agent the right tools is easy. Knowing what a tool actually is at the architecture level, that's where engineers separate themselves. 3 things turn a language model from a text generator into a functioning agent: tools, memory, and planning. And almost everyone has a fuzzy marketing level understanding of all these 3. But in this lesson, I want to give you the architecture level understanding, the real one, because that's the difference between building agents that work and building agents that look like they work in a demo and then fall over in production. This is lesson 4, tools, memory, and planning. Let's start with tools, because tools are the most misunderstood. Here's the technical definition. A tool is any capability an agent can invoke that either has real-world effect or returns information from outside the model. That's it. And that covers a huge range: web search, code execution, reading and writing to a database, calling an external API, file input-output, controlling a browser, sending emails, issuing refunds. If it reaches outside the model's interface paths and touches the world, it is a tool. And why does this definition matter so much? Because it is the line between what an agent can do and what it can only pretend to do. Listen carefully. A model that has been told in its prompt you can issue refunds, but has no actual refund API to call, it's not an agent. It's a chatbot playing pretend. The tool is the mechanism that makes the action real. The words in the prompt are not the action, the tool is the action. Now, here's how tool use actually works under the hood. And there's a crucial detail here. The model is given a list of available tools and their descriptions. When the model decides a tool is the next step, it outputs a structured call, a tool name, and some parameters. And then, this is the part: the system executes the tool, not the model. The result comes back, gets fed into the model's context, and the model continues. The model never directly executes anything. It only requests execution. Let me say that again, because it's one of the most important safety facts in this entire field. The model requests, the runtime executes. And here's why you should care. That gap between model requests and system executes is where you insert all of your control. In that gap, you can validate the parameters. You can enforce rate limits. You can require human approval. You can block a call that exceeds what the agent's allowed to do. Every single guardrail we build later in the course lives in that gap. The indirection isn't a technicality. It's the entire foundation of the agent's safety. And one principle on tool design, we go deep in this in module 2, but the foundation is this: tools should be well named, narrowly scoped, and honest about how they fail. Vague, overly powerful tools gives you overly powerful, unpredictable agents. A tool called do stuff is a loaded gun. When people say agent memory, they're usually smushing together 4 completely different things that have different architectures and different trade-offs. Let's separate them. In context memory. This is everything in the active context window right now. It's fast, it directly shapes the model's reasoning, but it's finite and it's expensive. Everything the agent has done and seen and concluded this session lives here until you run out of room. And then you gotta choose what to keep. 2, external memory. This is any persistent store outside of the model. This could be a database, a vector store, a file system. The agent reaches into it deliberately, usually through a search or lookup tool. This is what lets an agent work with way more information than fits in context. The cost retrieval takes time, and you risk retrieving the wrong thing. This, by the way, is the foundation of RAG, Retrieval Augmented Generation for agents. 3, episodic memory. This stores records of past interactions and how they turned out. Last time I tried this approach with this kind of customer, and it ended in an escalation. Honestly, this one is still underexplored in production today, but is a hot area. These are agents that actually get better across sessions, not just within one. And 4, semantic memory. This is structured factual knowledge. Product catalogs, policy documents, ontologies, usually retrieved and dropped into context at the right moment. The agent doesn't inherently know this stuff, but it just knows where to look it up. That distinction matters more than it sounds. And the last one, planning. Planning is just the process by which an agent decides what to do before it does it. And here's something people miss. At the simplest level, every single step of the loop we've been talking about is already a tiny act of planning. The model reasons about the situation and picks one next action. That's planning in a smaller scale, but you can get more sophisticated. You can have the entire agent generate a whole multi-step plan up front, evaluate options, anticipate where things might fail, and then execute against that plan while staying open to revising it when reality doesn't match that prediction. Now, this is really important. More planning is not always better. I want to push back on the instinct that elaborate planning equals smart agent. Planning costs tokens. It adds latency. It can lock the agent into a plan that turns out to be wrong. The right amount of planning depends entirely on the task. Simple, well-defined tasks, minimal planning. Long, uncertain, many-step tasks, that's where an upfront structure earns its keep. We cover the specific patterns, chain of thought, tree of thought, skeleton of thoughts in Module 2. And here's the mistake to avoid: treating planning as a one-time thing you do at the start and then never revisit. Agents that generate a plan up front and then march through it mechanically, never checking whether the plan still makes sense, those agents are fragile. Real agentic systems replan when what they observe stops matching what they expected. Here's the mental model I want you to keep. A plan is a hypothesis about how to reach a goal. An hypothesis gets revived when the evidence says it's wrong. A plan you refuse to revise isn't a plan anymore. It's just being stubborn. So tools give agent real-world effect. Memory gives it information beyond the current moment in 4 different flavors. And planning lets it decide before acting, as long as it stays willing to replan. In the next lesson, we set up back up to the big picture and tackle a confusion that is absolutely everywhere right now: the difference between generative AI and agentic AI. They're not the same thing, and conflating them leads to some genuinely expensive mistakes. Generative AI and agentic AI are not the same thing. And right now, in this field, people conflate them constantly, and it leads to a very specific and very expensive kind of confusion. So this lesson is about being precise. By the end, you'll be able to tell them apart instantly, and more importantly, you'll understand why the different matters so much for safety. This is lesson 5, generative AI versus agentic AI. Let's define both cleanly. Generative AI is AI that generates content: text, images, code, audio, video. You give it a prompt, it gives you generated content back. The interaction is basically one shot or multi-turn within a conversation. It's stateless relative to the outside world. And here's the key word: it's consequence-free, in the sense that generating a block of text doesn't inherently change anything out there in the world. ChatGPT drafting an email, that's generative. Midjourney making an image, also generative. Copilot suggesting the next line of code, also generative. Agentic AI is AI that pursues goals through actions. The defining traits, you already know them: the loop, tool use with real-world effects, and the ability to take actions that have consequences beyond the conversation. An agent isn't just generating content, it's doing things. It doesn't just draft the reply. It reads your email, checks your calendar, looks up a policy, drafts the reply, sends it, and updates the CRM. This is a fundamentally different category of system. Now, here's the most important difference between the two, and it's one word: consequences. Think about what happens when each one makes a mistake. When a generative AI produces wrong output, a human looks at it and either uses it or throws it away. The model's error doesn't go anywhere unless a human chooses to act on it. There's a person standing between the mistake and the world. When an agentic AI makes the wrong action, the action has already happened. There was no person in between. And that action might be reversible, like updating a record you could just update again, or it might be irreversible. It could send the email. It executed the trade. It deleted the file. You can't take that back. That's the entire reason agentic systems need a fundamentally different approach to safety than generative systems do. Here's the insight stated as sharply as I can. With generative AI, the errors are in the output, and a human is the last line of defense before anything happens in the world. With agentic AI, the errors are in the actions, and the system is the last line of defense, because the human might not even see what happened until after the fact. You need to sit with that asymmetry, because it drives every safety and governance decision we will make in Module 5. The human moved from being in front of the consequence to being behind it. Now, there's a second framing I want to give you, because it reframes the whole risk question. Generative AI is by design disconnected from the world, except through the human who reads its output. And that disconnection is not a bug. It's really just the safety property, like it's protective. Agentic systems deliberately throw that safety property away, but it's completely on purpose, in exchange for the ability to act. So the real question for any use case is just, is the gain in capability worth the gain in risk? And a lot of enterprise applications in 2026, the answer is yes. But only when the right controls are in place, never unconditionally. Here's the one-liner I want you to remember. Generative AI amplifies humans' ability to produce. Agentic AI partially replaces the human's role in a process. That second claim is so much bigger than the first, and because it's bigger, it demands much higher standards for reliability, for safety, for auditability. The best agentic teams internalize that from day one. Now, just to go on a quick tangent, what does this mean for something like my agency, where I build out AI agent systems and automations for my clients? In order to gain the upside of having all this capability to remove the human role in a process, we do have to make extra steps to make sure that the agentic systems that we build out are safe. And the mistake this whole lesson is built to prevent is evaluating an agentic system using generative AI metrics. If you measure an agent by how nice its text output reads, you have completely missed the point. An agent can produce gorgeous, beautifully reasoned text and still take the wrong action. The quality of the prose tells you almost nothing about whether the agent did its job. What actually matters for an agent is, did it complete the goal? Did it take the right actions? Did it stay within its sanctioned boundaries? And at what cost? Those are the metrics. Task completion rate, action accuracy, escalation appropriateness, not how good does the writing sound. Measure the actions, not the eloquence. So generative AI generates, and a human decides whether it matters. Agentic AI acts, and the consequence is already real. That consequence's distinction is the hinge that everything in production safety turns on. In the final teaching lesson of this module, we'll get concrete. We're gonna look at real systems, customer service, coding, research, DevOps, and classify each one honestly. This is where all 5 lessons so far click into place. Theory is useful, but the way you actually lock in everything we've built so far is to look at real systems and classify them honestly. So that's this lesson. We're gonna go across 4 domains: customer service, software development, research, and DevOps. And we're going to meet someone who's going to follow us through the whole rest of the curriculum. Her name is Arya. Lesson 6, what is and isn't an agent? All right, meet Arya. And no, Arya is not actually real. Arya is a customer success agent. A mid-sized SaaS company deployed her to handle inbound support tickets. And here's what she can do. She can read CRM data, query order history, look up product documentation, issue refunds, but only up to $50, escalate to a human agent with a summary of the context, and send emails, both template and custom. And I want to be clear, Arya is not actually hypothetical. She represents a class of agents being deployed in production right now. So is Arya an agent? Yes. And let me prove it by walking her through the 4 pillars. She perceives. She reads the incoming ticket, pulls the customer order history from the CRM, looks up the relevant docs, she reasons, she addresses the issue, figures out the right resolution path, and decides whether she can handle it herself or needs to escalate. She acts. She issues the refund, sends the emails, creates a follow-up task, escalates with a structured summary, and she observes. If an email send fails, she sees the error and either retries or flags it. And she loops. If her first attempt doesn't resolve it and the customer writes back, she reads the new message, looks at the whole conversation history, and tries again. All 4 pillars, a loop, that's an agent. So let me show you in one run. A customer writes, my order hasn't arrived after 3 weeks and I want a refund. Watch Arya's loop. Perceive. She reads the ticket, pulls the order record, sees it shipped 24 days ago, and the last tracking scan was 18 days ago. Reason. Okay, this isn't a delay. This is a lost shipment. And per policy, a lost shipment qualifies for a refund or a reship. Order total is $38. That's under her $50 limit, so she's authorized. Act. She issues the refund through the Payments API and sends a confirmation email with the timeline. Observe. The Payment API returns success. Email returns a 200. Goal met, loop ends. And here's what I want you to notice. What Arya didn't do. She didn't bump into a human. She didn't ask customer clarifying questions she could answer herself just by looking at the data. She didn't draft something for a human to approve. She just handled it. And the only reason why that's safe to deploy is that her tools, her authority limit, and her goal were all clearly defined. Hold that thought. We'll come back to it at the end. Now, let's do the opposite. The 3 most common things people call agents that aren't. 1. An LLM-powered chatbot with no tools. It can have a brilliant conversation about how to fix your order problem, but it can't fix your order problem. It's missing pillar 3, act. This #1 source of confusion out there, companies ship a chatbot with impressive sounding AI and call it an agent, but it's still just generating text for a human to act on. 2, a sentiment-based routing automation. It uses AI to classify, sure, but the routing logic is fully predetermined. The AI labels the input, your code decides what to do with the label, but there's no dynamic decision-making past that one classification. That's a level 3 system. Super useful, but not an agent. 3, a coding assistant that suggests your next line. That's generative AI doing the next token prediction inside a conversation. But, and here's the upgrade path, if you add a tool that lets it write files, run tests, read the test output, and decide what to change based on that, now you have an agent. Same exact starting point, but there's just one set of capabilities away from crossing the line from a level 3 automation and a level 4 agent. All right, so let's just round it out with 3 more domains quickly. Coding agents. These are among the most mature agents out there in 2026. You hand it a task, fix the failing test in module X. And it goes, reads the source, runs the test suite, looks at failures, edit code, run the test again. It will loop until the tests pass or hits a stop condition. Say 5 iterations with no progress, at which point it files a detailed issue and escalates. The difference between this and an AI-assisted IDE is exactly the 4 pillars. The IDE waits for you to invoke it. The agent operates on your behalf. The IDE suggests and you decide. The agent decides, implements, tests, and delivers. Okay, next, research agents. You give it a question. Summarize the competitive landscape for enterprise CRM software. Focus on pricing and recent product changes. And it autonomously runs searches, choosing the queries itself, reads results, cross-references claims, and decides when it has enough, and produces a structured synthesis. What makes that agentic instead of a really good search? The model is making strategy decisions. What to search next, which sources to trust, when to go deeper versus move on. Each round of search informs the next decision. That's the loop doing continuous synthesis. Third, DevOps agents. This is where the stakes get the highest. Picture a task. Investigate why the API is throwing elevated error rates and remediate if you can. It can query dashboards, read logs, restart services, change configs, deploy a rollback, page the on-call engineer. Full 4 pillars. It perceives the metrics and logs, reasons about the cause, acts by restarting a service or adjusting a config, and observes whether the error rate dropped. But look at that risk surface. Restarting production services, modifying config, deploying rollbacks. Those are consequential, sometimes irreversible actions. So a DevOps agent needs explicit limits, clear escalation paths, and human approval for the high impact stuff. Done right, it's incredibly powerful, but done without controls, well, that's how you wake up to a $12,000 compute bill, because the agent spent all night trying to fix a CI loop. So here's the insight that ties the whole module together. The right question for any real agent deployment is not, can we build this? The answer to that is almost always yes. The right question is, what are the boundaries of its authority? Every agent needs a crisp answer to 3 things. What can it do without any human approval? What requires approval first? And what situations force it to stop and escalate immediately? Remember Arya, she can issue a $50 refund on her own, but she can't issue a $500 refund. That one requires a human. And that limit is not a weakness. That limit is the exact thing that makes her trustworthy enough to deploy in the first place. Last teaching lesson of module 1. You've got the spectrum, the 4 pillars, the automation versus loop distinction, tools, memory planning, the consequences distinction, and now a gallery of real systems to anchor it all. In the next lesson, you're gonna do the work yourself. I've got 10 systems lined up, and your job is to classify every one of them. That's where this actually becomes yours. Hey, all right, so everything up to now has been me teaching you. This lesson will flip that. Now you do the work. I'm gonna give you 10 AI systems, and your job is to classify each one. This is the lesson that turns knowledge into skill, and don't just watch it. I believe that the best way to learn is to actually apply. So that's the purpose of this lesson. So pause, write, and then come post your answers in the community so we can argue about the hard ones together. This is lesson 7, classify the systems. All right, so here's exactly what to do for each of these 10. 3 things. 1, place it on the autonomy spectrum, level 1 through 5. 2, identify which of the 4 pillars it has and which is missing. 3, describe what you need to add to move it up 1 level and 1 piece of the process that really matters. Do this individually first. Write your answers down before you read anyone else's in the comments or in the community. I'm serious about this. It stops you from anchoring on whatever the first confident person said. The goal here is not for everybody to land on the same answer. There is not really a true correct one. The goal is to just practice the reasoning and the logic. Some of these are genuinely debatable, and the debate is the point. Let me read you the 10. I'll keep them quick. System 1, the document summarizer. Upload a document, get a bullet point summary. No history, no memory, no connections. System 2, the FAQ chatbot. It answers product questions from a knowledge base, keeps conversation history, but can't take action. Heads up, this one has retrieval. Does that make it an agent? Sit with that. System 3, the sentiment router. It classifies an incoming email and auto routes it to a queue with a templated reply. It takes real action. So is that an agent? Ask yourself who's actually deciding. System 4, the research assistant. Type a question, it runs its own searches, decides if it needs more, synthesizes a report, all on its own for several minutes. Map this one explicitly to the loop. System 5, the code reviewer. It reads a pull request. Now, it does post to GitHub. That's a real effect. What's the distinction? But is posting a comment the kind of action we mean? System 6, the autonomous bug fixer. It takes a GitHub issue, explores the code, writes a fix, runs the tests, and iterates up to 3 more times. It opens a PR or explains why it couldn't. This one's clearly an agent. Your job is to map full tool set, its stop conditions, and its escalation path. System 7, the scheduled report generator. Every Monday, it queries 3 databases and emails a generated summary. Fully automated. Touches lots of systems. But does automation equal agency? What would we have to change? System 8, the customer onboarding agent. New accounts trigger it, it sends a welcome email, schedules a kickoff, creates a project, assigns tasks, follow-ups after 48 hours. Is this a real loop or a very sophisticated linear automation? That's the debate. System 9, the competitive intelligence monitor. It runs nightly, watches competitors, detects significant changes, alerts Slack, and updates a persistent database. 2 things to chew on. Does running on a schedule change its autonomy? And how does that persistent database change the picture versus pure in-context memory? And System 10, the multi-agent procurement system. A planner agent delegates to parallel research agents, synthesizes, and hands off to a compliance agent that checks against policy before human signature. Find the orchestrator, find the sub-agents, and figure out where human review must be mandatory no matter what. A few hints to make your thinking sharper without giving away any answers. Systems 1, 2, and 7 are all built to test the automation versus agent, except System 2, the chatbot with retrieval. System 5, the code reviewer, is a great trap. Yes, it posts to GitHub, but push on this. A review comment is inherently advisory. It's a suggestion, not an executed action. Actions matter because of their consequences, and a comment's consequence is someone reads it. Systems 3 and 8 will generate the most heat for both. All right, so those are the 10. But here's the last thing. I want you to actually answer this one inside of the community. For every system you classified as not yet an agent, ask, would making it agentic even be the right move? What would you gain and what new risk would you take on? Because the quiet lesson of this entire module is that not every system should be an agent. I know, it's actually crazy that this entire lesson has been teaching you about how necessary and the importance of building out these agents, but really, I would say most processes should just stay to level 3 automations. Post your 10 classifications in the community thread for this lesson. I read them and jump in on the ones people are split on. That's the whole point of doing this here instead of alone. I'll see you in the wrap-up. All right, that's module 1. I hope you enjoyed. But before you move on, let's lock in what you should now be able to do, because everything in the rest of this curriculum is built on top of this foundation. If any of these don't feel solid, that's your signal to go back and not to push forward. By the end of this module, here's what you should own. You can define an agent precisely, not the lazy version that AI does things, the real one. A system that perceives its environment, reasons about a goal, acts through tools, and observes the results in a loop. You can take any AI system and place it correctly on the autonomy spectrum, from a bare LLM API call all the way up to an agent network, and explain what new capability each level adds. You could spot the 4 pillars: perceive, reason, act, observe in any system. And more usefully, when a system is failing to behave like an agent, you can name which pillar is missing. You can explain the most important line in the curriculum, the difference between a linear automation, where a human pre-wrote every branch, and an agentic loop, where the model decides what to do next based on what it observes. You can articulate why tools are the thing that gives an agent real-world effect. And you can name the 4 modes of memory: in context, external, episodic, and semantic. And you understand planning as a hypothesis to be revised, not a script to be obeyed. And you can explain the consequences distinction between generative and agentic AI, and crucially, why that one distinction drives every safety and governance decision you make in production. You can classify real systems correctly using ARIA, coding agents, research agents, and DevOps as your reference points. And finally, maybe the most mature thing on this list, you can articulate why not every system should be an agent. And you've got real criteria for deciding whether adding agency is worth the extra risk and complexity. If you can do all that, you're genuinely ahead of most people working in this space. And when I say most, I mean like 99% of people in this space right now, including a lot of people who'd call themselves experts. This foundation is the thing that keeps you from getting fooled by a fancy demo or building the wrong system for 6 months. In module 2, we go from what is an agent to how do you build one. Tool design, prompting patterns, and the planning techniques I keep teasing. It gets hands-on fast. Take a beat, make sure this module is solid. Post your exercise answers if you haven't, and I'll see you in module 2.